I'm about to start the Getting Started with Raspberry Pi session, and in this session, we're going to talk about what Raspberry Pi is, what you need to get started, and what people have done with it, and what cool Raspberry Pi projects are going on all over at Maker Faire. And you'll see lots of Raspberry Pi projects as you walk around at Maker Faire. A little bit of an introduction of myself. My name is Matt Richardson. I'm a contributing editor for Make Magazine, the fantastic publication that puts on Maker Faire. I'm also a resident research fellow at NYU's Interactive Telecommunications program, also called ITP. It's a 2-year grad program that focuses on the intersection of arts and technology, and I'm a resident research fellow there. And if you like the kind of stuff that you see here at Maker Faire, you'll love the kind of stuff that ITP students are doing. I'm also the author of Getting Started with Raspberry Pi, or the co-author with Getting Started with Raspberry Pi. I wrote it with a friend of mine, Sean Wallace. So a lot of the stuff that I'm talking about is also covered in the book, and then we go beyond that and show you how to make some cool projects, some internet-connected projects, and how to build cool hardware with Raspberry Pi. So, all right, what is the Raspberry Pi? Essentially, it's just a computer. You can plug in a keyboard, monitor, mouse. You can use it like a computer. You can plug it in, you can get it online, you can surf the web on it if you wanted to. Now granted, it's not as powerful as the computer you probably have, but it is a computer nonetheless. Now it really was made for education purposes. The Raspberry Pi Foundation is a nonprofit foundation that created it to help students get an earlier start with hacking with hardware like they used to a long time ago. So let me give you a little bit of a tour of the board a little bit so you can get a sense of what's going on Raspberry Pi, because it doesn't look exactly like a computer you're used to. For one thing, it doesn't have any kind of enclosure. It's just a bare board computer. The chip on it is the similar kind of chip you'll find in a cell phone, like maybe a first-generation iPhone. That's the kind of power Raspberry Pi has, not super duper powerful. And if you're into specs, it's an ARM11 700 megahertz processor. It has 512 megabytes of RAM in the Model B version. Let's see. It has video outputs, and it's got 2 of them, actually. So if you have an HDMI television or a new digital monitor, you can hook it up through the HDMI port, which is shown on the bottom there. On the top, you have a composite video output and analog output, and that lets you connect it to an older television set. So you could use, like, if you have an old TV, scrap TV laying around, you can hook a Raspberry Pi up to it and make a project out of that old TV, which I think is a fantastic way to use Raspberry Pi. Just like a computer, the Raspberry Pi has USB ports. It's got 2 of them. This is how you're going to hook up a keyboard or a mouse to it. You can also hook up all kinds of different peripherals. I did a project where I hooked up a webcam to it, and I'm actually going to be talking about that tomorrow afternoon in my presentation about how to hack Google Glass and how to connect it to the Raspberry Pi. This part right here, this is an Ethernet port. Again, just like on your computer, this is how you'll connect it online. Plug it into your router, it'll get an IP address, it'll get the internet connection through your internet connection. And if you don't have access to a plug-in internet connection, you can also plug in a USB Wi-Fi device and get onto a Wi-Fi network as well. And it's actually not that hard at all. There's a little tiny jack on the bottom left side that you see there. That's a micro USB jack. It just gets power through that. So if you want to power it, any kind of cell phone charging cable will do just fine. On top, there's an audio output jack. You can plug in headphones or speakers or something. That's how you can get audio output out of Raspberry Pi. And then there's this funny little connector here. You're probably not familiar with it because it's usually a kind of connector you find inside a cell phone. And it's how a cell phone manufacturer would connect the camera component to the actual board of the cell phone. So right here it is for you to use. And so the Raspberry Pi Foundation made their own board, their own camera board, which connects to the Raspberry Pi through this connector. It's called a camera serial interface. If you don't have the special Raspberry Pi camera, you can actually also just use a regular USB webcam. As I said before, I did that in a project before. Now, one of the features of Raspberry Pi that a computer doesn't have, or you usually don't see on a computer, are these pins that I have squared in the upper left here. These are general purpose input and output pins, GPIO pins. How many of you are familiar with an Arduino or have used an Arduino before? These are just like the pins on an Arduino. So you can connect hardware to it, you can connect electronics to it, you can read the state of buttons and switches. If you want to connect a relay and turn the house lights on and off, you can do that through these pins. This is something you typically don't see on a computer, but this is a great way, and this is why we at Make and why people at Maker Faire use Raspberry Pi a lot, is because we can use this in our projects very easily. This is how we interface with things. So yeah, that's another look at what those pins look like from the side. This is how I'll connect like a lamp to my Raspberry Pi by using a component called a relay to switch on and off the lamp. I think the best feature of the Raspberry Pi is its price. And I don't work for Raspberry Pi Foundation. I'm not trying to sell you on Raspberry Pi, but I think it's phenomenal that for $35 you can have a full-on computer and you can hack and play and just mess around with it. And it also means that you can dedicate the Raspberry Pi to a project. So if you have a project that needs kind of computing power, you need USB access, you need this or that, before the Raspberry Pi, you were talking about spending at least $100 for some sort of computer-like thing. Raspberry Pi, when it came out at $35, it meant that it was a small component of your project. I mean, it could be a central component, but it wasn't a big component of the budget. And so I have a stack of Raspberry Pis at home that I can grab from if I need to throw one into a project and I don't want to worry about, like, getting it back. I can screw it down into the project and say, oh, whatever. It was only $35. Now, if $35 is too expensive, there's also the Model A. The Model A goes for about $25, and the main difference is it doesn't have that onboard Ethernet port that the Raspberry Pi does, and it only has one USB port on the side. Another difference is that it has half the amount of RAM, but you get all that for $25. If you don't need the Ethernet, you don't need the extra USB, so this is a good one to use, I think, because it also uses less power. Ethernet draws a lot of power when you want to connect it to a network. So this is a perfect choice, not only because the price is lower, but because it uses less power. I think the fantastic thing about that price, that $35 or $25 price, is that it allows you to, what Linus Torvalds said is afford failure. And the full quote here is this, and he said this to BBC News maybe a year ago. I find things like the Raspberry Pi to be an important thing, trying to make it possible for a wider group of people to tinker with computers and just play around, and making computers cheap enough that you can not only afford the hardware at a big scale, but perhaps also afford failure. I think that's the important thing here, is that if you had a computer that was, let's say, $200, you would be a little bit afraid to mess around with it. You'd be a little afraid to hack with it. You'd be afraid of messing it up. And if you only had one computer in your home and the whole family shared it, you didn't want to put that computer out of commission. So what the Raspberry Pi allows is for someone to have a device, perhaps it's a kid that wants to hack around without any kind of repercussions. I think this is a fantastic thing. And Linus Torvalds is the father, he's the inventor, he's the founder of Linux, which is a free open source operating system. And it's what the Raspberry Pi runs on. Many computers use Windows, Mac, some of them, I'm sure some of you do run Linux on your desktop machines. It's the operating system that runs on web servers many times. This is the operating system that's loaded on Raspberry Pi. And it's wonderful because it's free. You can find other operating systems to load up on the Raspberry Pi if you'd like. It's definitely an option. But the Raspberry Pi Foundation offers a specifically packaged operating system that you can load on called Raspbian. And Raspbian, you'll load onto you'll load onto the Raspberry Pi. You'll get a desktop environment if you want it. You can use your keyboard, monitor, mouse. You can surf the web with it. It has a web browser. It has different ways to program it. You don't have to use the desktop environment, though, and you don't have to use a monitor and mouse and keyboard if you don't want. You can also just hook the Raspberry Pi up to your network and then log in remotely if you'd like as well. The possibilities are really endless. I want to talk about some of the other things you're going to need if you want to get started with Raspberry Pi. For one, you'll need a power source. And many cell phone chargers, USB cell phone chargers, they'll work just fine. Anything that provides power over USB, that's 5 volts, that'll work great. You just want to make sure it gives you enough amps. If you look on the bottom of the power source, it'll say maybe 1 amp. You want to have at least 1 amp, or it'll say 1,000 milliamps, MA. You just want to make sure you have enough of that, of the current that that your adapter is going to provide enough current to power the Raspberry Pi. So not all cell phone chargers will provide that, so you just want to keep that in mind. Of course, you need to connect that power supply to the Raspberry Pi. A standard USB cable with a micro USB connector on one side, that'll do you fine. Now, instead of a hard drive, the Raspberry Pi uses an SD card. This is just like the SD card that you'll put in a digital camera. So these are the kinds of things you can buy nowadays in a drugstore, or you can order them from Amazon. I think probably like $5 you can order one of these. I recommend at least 4 gigabytes. Class 4 works really well if you want to get technical about which type of card to get. But you can use a card that's as low as 2 gigabytes as well. If you want to use it directly, you can use a keyboard and mouse, as I said before, USB keyboard and mouse. If you want to add more USB peripherals, you'll want to use a USB hub to connect more. Just like if you connect a hub to your computer to connect lots more USB devices, you'll use one of those. I recommend getting a powered USB hub. That's a hub that provides its own power to the peripherals you're connecting, because the Raspberry Pi won't be able to provide much more power than to power a keyboard, mouse, and maybe one other thing. So keep that in mind if you're connecting lots of USB devices to your Raspberry Pi. Of course, a monitor. You'll want to use a monitor when you're first setting it up. HDMI monitor, or you can get like HDMI to VGA adapters to connect an older monitor, or you can use a TV screen as well. The Raspberry Pi doesn't come with a case, and you can buy a case like this one. This is one Adafruit sells. I think it's about $10. Looks like this. It's a really nice case. Pimoroni over there, they sell cases too. They're beautiful. They're rainbow. I definitely recommend checking them out. There's tons of different kinds of cases in the Maker Shed as well. You don't have to buy a case. I usually don't use a case. But if you do want a case and you don't want to buy a case, you can also just make a case. And lots of people have made really cool cases with things like Lego, or milling their own metal, or carving them out of wood. We've seen at Make tons of fantastic cases for Raspberry Pi. Again, not a requirement, but it's nice to have. So how do you use the Raspberry Pi? What do you use it for? Well, if you're interested in programming, you can use a programming language, a graphical programming language called Scratch, which lets you drag and drop different components to make an animation, or to even make a game if you wanted to. So you'll drag things onto the stage. You'll have these sort of tools you can use. If you're already beyond the point of drag and drop programming, you can program your Raspberry Pi in Python, C, Java, what else is out there? Ruby. I mean, all these things will run on Raspberry Pi, and you can program it with whatever language you want, pretty much. I think that's an amazing strength of Raspberry Pi. Whatever you're comfortable with, you can get started with. And if you're totally new to programming, if you've never written a line of code in your life, and you want to skip over the graphical thing, I recommend checking out Python. And Python is what we cover a lot in Raspberry Pi, because it's a great starting programming language if you're just getting started. So I want to talk about some ways people have used Raspberry Pi, because we know it's a computer, we know you can program it, but what can you do with it? Now, I want to show one project that I made first. I bike around New York City. I'm from Brooklyn, and I thought it would be neat to make a project that put the Raspberry Pi on my bike. And I thought it would be neat if my headlight, in the beam of my headlight, I could see information about my ride. Where I was going, what time it was, what speed I was, how far I went, how many calories I burned. I thought that would be pretty neat. And I thought the Raspberry Pi was a perfect solution for that. So this is what I call sketching in hardware. This is me. I took a piece of thin wood, plywood. I popped on a Raspberry Pi on there. I put a breadboard on there and a battery pack, and I powered the Raspberry Pi with a battery pack, and I connected the front wheel of my bike to the Raspberry Pi so that I could get the speed off of the front wheel. And on the front of the bike, I put a little tiny battery-operated projector. And effectively what I made was a dynamic front bike headlight. You'll see me trying it out. This is me trying it out on the first time on the streets of New York City here. And there's the speed of the bike projected in the beam of the headlight. Now, as I said, it doesn't have to be the speed. It could be any kind of information you want. You can program it to do whatever you want. Now, I'm usually not so bad at biking here, but I had the camera right in my torso, and I was trying to hold the handlebars. And, but yeah, I don't recommend biking around the city like this. So as I said, you can put any kind of information you want in the display of the Raspberry Pi, and this is a nice mobile application for Raspberry Pi. tomorrow, I'm giving a talk about how to hack Google Glass. And I use Raspberry Pi as a remote camera location so that when I'm wearing Google Glass, I can see into an area. And when I look around, the camera moves. So I'll be talking about that tomorrow afternoon, if any of you will be back for that. While you're here at Maker Faire today, though, if you want to check out some Raspberry Pi projects, if you go inside NiSci and on your map it's labeled Zone A, Tom Calloway from the Fedora project is showing a Pi-based 3D printer. If you want to check that out and talk to him, that's inside NiSci in Zone A. And also, NYC Resistor set up this interactive multiplayer game. It's also in Zone A, inside NiSci. It's called The Future Crew, and you get to interact with all these old devices, and they all have Raspberry Pis inside, and that's what makes them run again, and that's how you kind of interact with their game. I haven't had a chance to play it, but it looks really, really cool, and they look like they've done a really good job on it. So when you get a chance, go inside NiSci. You want to go down into the gallery and check out their project there. If you want to learn more about getting started with Raspberry Pi, of course you can get the book, Getting Started with Raspberry Pi. It's available on Amazon. It's also available in the Maker Shed. There's also Getting Started with Raspberry Pi kits that have the book and the Raspberry Pi and an SD card and a power supply, all those things you need except the keyboard, monitor, mouse. So you can plug it into your own stuff. So with that, I'm happy to take any questions if we have time. We have time for questions, I think, right? Yep. Any questions about Raspberry Pi? You'll have to speak up really loud because I have a hard time hearing. You don't have to solder anything. You can just prototype with the board and the breadboard and use jumper wires. You'll want to solder when you want to make a project that's a little bit more robust. But you can do a lot, and you can do prototyping without soldering. Yes? So no, you really can't program those GPIO pins. The question was, the GPIO pins on the Raspberry Pi, can you program them with the Arduino IDE, the development environment that comes with Arduino? Those pins can't be programmed with the Arduino IDE, but you can hook up an Arduino to the Raspberry Pi and program an Arduino with the Raspberry Pi. Great. Cool. I should get going. I should move off stage so the next person should get on. I'm happy to take any questions off to the side as well. Thanks for coming, and enjoy the rest of your day at Maker Faire. Bye.